the next group of application is a little bit different, and it targets the building and district level analytics towards the optimization of energy performance management of buildings and districts level. And the target users here is, according to the nature of application, are ESCOs, building owners, city decision makers, facility managers. And in Synergy, we developed together with partners, VTT, Circe, Vert, ETRA has been involved. The optimized energy performance management suite, which consists of these 4 tools or application, like we call them, that you can see here in this slide. One is Advanced Renovation Support application. We support these target users and help them to plan their renovation action based on real data from the building. Another one, Urban Energy Monitoring and Planning Support tool set, support primarily urban planners to follow the energy efficiency of districts in the city and to plan the mid and long-term climate targets related to energy, but also non-energy aspects. The third kind of application or a set of tools is related to the optimization of to self-consumption optimization and predictive maintenance buildings functions on buildings and district level for self-consumption. And then the last one, but not least, the application which support the real-time building energy performance assessment and smart readiness assessment of the building. And the same like in the previous applications, this application use also extensively the data from Synergy platform and also some baseline analytics and workflow developed in Synergy. Some key, let's say, innovation features to bring your attention to, like, for example, for innovation support is a unique tool. We use the real data to construct the baseline of the building, and then tool you will see now through the demo is able in 5-10 minutes to calculate various alternative renovation scenarios with indicators showing energy consumption, carbon footprint, investments, energy consent, a playback time, for example. Then you do various renovation actions. And then urban planning is unique in the way that it takes in planning not only the energy aspects, but also non-energy aspects in long term, business, social, policy, technology acceptance. And then regarding facility management and predictive maintenance supports, here also the applications are able to flexible take various parameters, constraints of the grid, and also availability of storage and renewable technology to generate the specific operational points on the building. And also the predictive maintenance components are equipment independent and able to propose some optimization possibility based on real data from buildings. And the last application, real-time building energy performance and smart readiness assessment support, it supports the dynamic near close real-time assessment of building energy performance, and there is currently no such tools developed ready to use that produce the certification of the building according to the recent SRI methodology developed and supported by European Commission. And so now we are going to the live demo, and we start with renovation support, and then we also show you some features from facility management applications presented. First will be presented by VTT, next by Circe, and last regarding the performance assessment of building will be presented by Vert. Yeah, please, Kalevi, VTT first.
Thank you, Julia. So this advanced renovation support tool, as Julia mentioned, is the fast method for analyzing building and energy renovations. And results of this tool is heating, cooling, and electricity energy savings, and also same energy cost savings. And carbon footprint, investment cost of those renovation actions, and also payback time for this renovation action. And the innovative feature in this tool is that it can learn building model parameters from measurement data, energy measurements, and also weather data. So it makes digital copy of it, and that can be used as a baseline for this tool. And target user for this tool is building management and construction and ESCO companies and building owners. And here is figures which kind of results it give. There is those savings and carbon footprint, investment, payback time, and all those analyzed renovation actions. And there is the process how it learns this model. But let's go to fast demo, which is there is the link for this tool, and I sign on Keylog to Synergy platform and select one building, for example, apartment building, and let's take that it's for example built in 70 and it has, for example, 7 floors, gross floor area is 2,000 square meters. There is 100 people in that, and 30 dwellings. Old boiler space heating system, no other heating systems, and direct electricity, and water heating is also this, and no other water based systems. And now we have the basic information which we need. Then it reads default value for this case. For building group, there is outside wall U values and ventilation related air sense rate and schedules and building parameters. These are default value for that type of buildings, also schedules and internal heat gains, residential appliance related heat gains, and residential lighting gains. But now there is that kind of feature that if we have that energy and weather data, it can learn all those parameters by the data which is described here. It try to fit those hourly based energy, heating, cooling, electricity, and temperature levels so that the difference is very small. And when we have learned those parameters, we can, for example, change that this ventilation rate was something else. It was here, and it Saturday it begins only at 7 o'clock, and so on. And for example, U values was little bit different. It was something like this, and then we can continue. We select weather for this. For example, we take Helsinki Kumpula weather station weather and year 2020. And based on this data, now we get a baseline for this building, so that it has learned those parameters which are not known from energy measured energy consumption and weather data. And there is the space heating, yearly base heating, and hot water, electric consumption, appliance, LSC, space cooling, carbon footprint, energy cost investment, and payback. Of course, these are not yet because we have not had a renovation plan. And now we can select different kind of renovation plan here. For example, if we take ground source heat pump here, we click it and then checked how much this ground now it's evaluation this ground source heat pump savings. So we see that the electric consumption, heating consumption is much more lower, and payback period is 9 years. And if we add some other renovation plan, for example, new windows, and check the same issue. In this way, we can select all these renovation plans and check which of them are best from different point of view. So now this window is not very good because its payback time is 47, and of course we can see here hourly level how this system what is, for example, here is ground source heat pump, here is the original situation, and here is window related values, and there is huge amount of other values which we can show, but maybe it's not enough time. Okay, I can show only those lists which is available here, so that, for example, if we are interested space heating carbon footprint related values, so then we have here how its effects on carbon footprint topic. So that was all of my presentation. So thank you.
Hello, I'm trying to share my screen. Can you see it?
Yes, we can.
Okay, thank you. Well, first of all, just to justify why do we need this kind of self-consumption optimization tools, just to highlight some ideas. Okay, first of all, electric prices are rising, affecting economic development of families and business. In recent years, distributed generation technologies have become more and more widespread and developed. And thanks to the latest IT system, distributed generation, storage, and different kind of energy demands can be monitored and controlled. So self-consumption optimization tools are emerging as a method to reduce energy cost in different environments. Okay, so this is why we have developed two tools for building and facility managers, ESCOs, our target users. And they are the building level EPOM, a tool to optimize the consumption, the self-consumption of single buildings or single consumers, these single users, and district level EPOM, DL EPOM, to optimize demand of groups of buildings or group of users. Okay, so the objective of these tools is to reduce energy cost of different type of consumers, calculating optimal operation set points for manageable devices, battery storage systems, electric vehicle charging stations, solar PV generation systems, and also manageable loads, manageable demands as household appliances or HVAC systems. Now let's see the tool. Let me switch into the tool. The first, you have to be logged with a registered user and password, so each user can only have access to its own building characteristics and data and results. Okay, in this case, I have used my own data and users to access this building. And well, here we can see we have 3 tabs for the building level optimization, selection and inputs, optimizations, and optimization results. In the first one, we can see information about the building, the grids, the grid where it is connected, the type of building, and so. And we have also some, let's say, static characteristics that provides information about the building. First of all, related to battery storage systems, charging and discharging powers, maximum and minimum batteries SOC, state of charge, also related to electric vehicle charging station, and the connection with the grid, the maximum power. Okay, and we have some inputs here. As we can see, if we return for a while to the presentation, this building data can be or is stored in the Synergy platform, and using the APIs provided by the platform, we can download this data. First of all, as we have said, the building parameters, grid connection, characteristic of storage system, and so, and also some forecast data, PV generation, electric demand, and so, as we can see here. So for this example, we can see here PV generation, electric prices, and non-manageable demands. We can see here this data in a graphic way, but we can see also the same information, but in a table, okay, with all this data. In this tab, we can launch the optimization process. And here in the last tab, we can see the result of this optimization. We see the results date, the timing of the last execution. We have this time in the time of the location, on the local timing of the users, and here we can see the results of the energy, for example, the energy exchange with the grid, the energy used from the grid, and the energy sent to the grid, the building consumption, for example, the PV generation, and the PV, the batteries state of charge, batteries power and discharging power, and so. The first step of this process, let's say, is that every user or every building manager install on his premises different sensors, smart meters, and so, to provide this information to the Synergy platform so we can download it, access this information. All these tools have been programmed in Python using different kind of different libraries. The most important one is the GuroVP, the GuroV solver, or the optimization engine. Okay, and as we have seen in the real demo, the output of these tools are an optimal precision set points for these manageable devices: battery storage system, electric vehicle charging system, and solar PV. And well, that's all from my side.
Hi everyone from my side as well. Let me share my screen. Okay. So the last 2 set of tools for the facility management monitoring engine is the Enhanced Display Energy Certificates tool and the Smart Readiness Indicator. Just a quick overview. Both those tools are kind of a sub-module applications which are related also to facility management and monitoring of the buildings, and that's why they are part of the general FMME tool. The Enhanced Display Energy Certificates is kind of an upgrade from the performance certificates that are very common, that are used from all facility managers. Basically, the aim of this application was to try and increase the real-timeness of the performance certification of one building by introducing actual data to the performance assessment of the building. So by connecting the application to the Synergy platform, we are able to draw information and data from the platform, having in place the contracts that have been mentioned by my colleagues earlier, and then compare the actual data of the building to some benchmarks, thus being able to assess the performance of the building in different spatio-temporal granularity. And then the second application is the Smart Readiness Indicator that I'm also going to present here. A couple of things on the Smart Readiness Indicator. This is a new tool that has been proposed by the EU in 2017, basically in order to extend the assessment of a building and perform a new type of assessment, which would calculate the capability of a building to apply different energy saving techniques, respond to the user needs, and offer services to the grid. This tool has been proposed in order to complement the performance certification tool of the different countries. And the idea here is that a different assessment will be performed by some energy professional in one building, by including information about different technical domains, about different systems that are installed in the building, in sort of scoring exercise, and aiming at producing a single SRI score that would quickly inform the users of the building on the smart readiness level of it. The tool is kind of innovation for this project, since there has been no tool currently developed as an online assessment that has been using this methodology. And also the innovation of the tool being connected to the Synergy platform is basically the fact that it can draw data from the platform for the energy users with the contracts that we have been referring to, and thus reducing by a considerable amount of time the time needed for the assessment. And now let me quickly move on. So for those tools, we are using the same facility management monitoring engine front end that has been presented by Gregorio earlier. So having the same capabilities and the same functionalities, we can introduce some building settings to the buildings. We are logging in by using specific credentials, thus being able to see only buildings and only users with which we have established the different contracts through Synergy platform. And we are able to insert or change the information that are already drawn from the Synergy platform for this specific building. We are able to choose a different layout to upload in the application. We are also able to link different energy sensors to different zones of the building, and thus creating the background of the building that we want to assess if the information is not already available in the platform. By going into the Enhanced Display Certificate user interface, we select the building that we want to assess. We see the layout, and then we can go directly and perform an energy assessment into whichever spatio-temporal granularity we want. I will go into the previous year because at the moment some of the sensors are not working properly in the buildings that we have made the contracts with. So I'm going back to June 2021, just a random date. And as you can see, I can select data up to 5 minutes granularity. Depending on the granularity of the data that are available in the Synergy platform, we will see the assessment being performed. And we can perform the assessment for 5 different hours. We can see the data, we can see the energy certificate of the building for this specific time period, the electricity that's consuming compared to what it should consume based on the benchmarks and the carbon footprint. And in case there is a electricity generation in the building, such as PV, we will also be able to see that. The assessment can also be performed in a much larger period of time, let's say a couple of months, where we will see information about the building. We will also be informed in case there is missing data of the different sensors, and thus we can have an overview of the performance of the building in different times, meaning that we can assess whether the building is performing as it should throughout the year, or whether there's a specific period of time that the building is underperforming or overperforming. Being able to have some better details on the data. And obviously, we will be able to export the report, which is being downloaded as a CSV file. Moving on to the second tool, the Smart Readiness Indicator. The idea with the assessment performance is that we can start performing the assessment. As you will see, this is a very time-consuming process, and that's why we will only do a test here. I will show you an already performed assessment. But basically, what we can do by connecting the application with the Synergy platform is pre-fill some of the details of the building that we want to assess by using information from the platform. If we choose a building that is already available, some of the information can be already pre-filled. We can perform assessments in two different types. Assessment A is a more simple one. Assessment B is a more detailed one, meaning that we need to assess more domains of the building. The different domains are heating, domestic hot water, cooling. They are all related to different systems that are installed in the building. And within each domain, we can go and assess the performance of a specific service of this domain, and thus being able to perform a complete assessment of the smart readiness of the building. Let me just quickly save that. We can also choose whether the domain we want to assess is absent or present, and whether or not the assessment of this specific domain, we think it's mandatory or not. Because there might be the case that for a specific building, electric vehicle charging is something that is not mandatory to be installed, and thus we won't need to assess it, and thus significantly reducing the time needed from the user. If I click Save here, I can perform an assessment. My computer is a bit slow at the moment, but I can go back and show you an already performed assessment. Let me just check that. The more services that we can choose, the more information we see on the board. Okay, my connection is a bit slow at the moment, but I think we can. I think we can end the assessment. We can end the presentation here. I don't know why I'm not able to load. I can show you that one. Basically, the different functionality levels that I mentioned before for the different domains. For each service, we choose the level that we think is indicative of the type of the service and of the way the service operates. And by selecting a field for each one, we perform basically an assessment. If we click on Submit, we see the impact of each domain for its functionality level and a total SRI score. This tool is meant to complement, as I said, the energy performance certificate of the building by introducing the concept of smart readiness. Okay, and that's it from my side. Thank you very much for your patience.